Okay, so think about Python dictionary, that thing you use every single day. You write something like apple bracket equals 5 and it just works. But have you ever wondered how it looks something up so fast? No matter how many keys are in there. It's not magic, it's a hash table underneath. Today we are gonna build one from scratch. No dictionary, no shortcut, so you can actually see what's happening inside. So here's the idea behind a hash table. Instead of storing your data in a list and scanning through it to find something, you use a function that turns your key into a number. That numbers tell you exactly which slot to check. No scanning, no searching. You just go straight to the slot. That's why lookups are fast, even with a million keys in there. The function that does this conversion is called a hash function. Keys goes in, numbers come out. Let's build one. Alright, so first, buckets. This is just a list of empty lists. One slot for every possible index. Now the hash function itself. It looks a bit mathy, but it's a simpler than it looks. We walk through every character in a key and build up a number as we go. We multiply by 31 each time and add one character code. That big mod number in there just keeps the value from getting too large. And this last line is the important part. Mod self.capacity. It skews whatever number we build down into a valid slot index, somewhere between 0 and capacity minus 1. So no matter how long the key is, you always get back a valid slot to check. To insert something, we hash the key to get our index. Then we grab that bucket. One detail worth noting. We loop through whatever already in that bucket first and check if that key already exists. If it does, we just update it in place instead of adding a duplicate. Otherwise, we append this new key value pair and increase our size counter. The bucket itself is a list, not a single slot. That's on purpose. We'll see why in a second. So what happens when two different keys hash to the same index? It's going to happen eventually. No hash function avoids this forever. That's just how the math work out. This is called a collision. And it's not a bug. Every hash table had to handle this somehow. The way we are handling it here is called chaining. That's why each bucket is a list and not just one value. If two keys land in the same slot, they both just live in that list together, side by side. When you go looking for one of them, you check that slot and then scan the short list inside it for the exact match. Let's just watch this happen. Quick get function first. Same idea. Hash the key, then scan that bucket list for the match. Apple and berry, two different words, both hash to index 2. That's a real collision, happening right there. And get still works. It hashes to slot 2, finds two entire setting there, and picks out that one that matches. That's how the collision get handled. One more piece, and it matters just as much. If you keep adding keys to a table that never grows, every bucket eventually turns into a long list. And once bucket get too long, you're basically back to scanning through a list one by one. That's defeat the whole point of a hash table. So hash table tracks something called a load factor. That's just how full the table is, size divided by capacity. Once that crosses a threshold, usually around 70%, the table resizes itself. It doubles its capacity and rehashes everything into the new bigger hash table. So we double the capacity, clear the buckets, and reinsert every key we had before. We have to actually reinsert, not just copy the old bucket over. That's because the capacity changed and our hash function uses capacity in that final mod step. Same key, different capacity means a different index now. So everything gets reshuffled into its new correct slot. And this one checked at the end of insert. Now it grows itself automatically whenever it gets too full. Let's start a fresh table, small capacity of 4. We'll insert 3 keys one at a time and print the state after each one. Watch the capacity column. After A and B, we are still at capacity 4. But once we insert C, size hits 3. Load factor crosses that 70% line and capacity jumps to 8 automatically, right in the middle of that insert call. That's the resize happening exactly when the load factor crosses the threshold. So that's what inside every dictionary you have used. A hash function that turns key into a slot number, buckets that hold a list to handle collision, and resize step that keeps things fast as it grows. That's the whole thing, maybe 40 lines total. Full code in the description. If you want the next one to cover open addressing, the other way to handle collision with no list involved, let me know in comments. See you in the next one. Peace.